let's try a hypothesis test using a t-distribution because the population standard deviation is not known. We'll use our test to determine whether truckloads of waste contaminated with cadmium should be sent to a sanitary landfill or a hazardous waste landfill. If the mean level of cadmium does not exceed 1 milligram per liter, then the trucks may go to the sanitary landfill. So let's let the null hypothesis be that the mu of the cadmium must be less than or equal to 1. Assume that 12 samples are taken and the average cadmium level of those samples was determined to be 1.08 milligrams. The sample standard deviation has been calculated for you to be 0.2 milligrams. Assume the population would be normally distributed and the level of significance should be 0.01, so should be very confident in our results. First of all, let's write the null and alternative hypothesis. Cadmium cannot exceed 1, which means at most the cadmium level can be 1. So we're going to put that here. And we'll put the complement down below. You're trying to determine whether the trucks are safe enough to go to the sanitary landfill. So let's make that one the claim, although that's a little arbitrary here in this problem. We should determine now what type of test this is. Is it a right-tailed test, a left-tailed test, or a two-tailed test? So you can judge the type of test by the null hypothesis, if you wish. Our null hypothesis says that the mu cannot exceed a certain level, which means that if it did exceed that level, then we would want to reject that null. That makes it clear to us that this is a right-tailed test. If it's 1 or below, it's safe. We would fail to reject. However, if the cadmium level gets high enough, we would need to reject the null. Okay. Let's look at the alpha level. The alpha level is 0.01. So let's mark that. And let's write down our N. (12 samples). Our degrees of freedom are N minus 1, so our degrees of freedom are 11. Now we have everything we need to look up in the table an alpha of 0.01 for a one-tailed test and a degree of freedom of 11. That will give us the TC cutoff value. So for a one-tailed test, alpha of 0.01, degrees of freedom 11, we have a TC of 2.718. Okay. Next, we'll try to find what is called T star, the standardized test statistic. For this type of test, the formula is very similar to the other problems. We'll do x bar minus mu, but we'll have, instead of the population standard deviation, we'll use the sample standard deviation because that's all we know, and then divide by the square root of n. So that's going to be 1.08 minus 1 over 0.2 and the square root of 12. It's 1.39. Now we should place our standardized test statistic on the graph itself. And we are not in the rejection region. Even though our sample is above 1, it's not enough statistical evidence to prevent the trucks from going to the sanitary landfill. So we will fail to reject HO. First we make a decision about HO. Then we write a conclusion about the claim. At the alpha equals 0.01 significance level, there is not enough evidence to reject the claim that the mean cadmium level of the truck's contents is at most 1 milligram. Therefore, the trucks may go to the sanitary landfill.